Hello, sir.
Hello, hello. Okay. So reciprocity, this is our reciprocity theorem, and it is telling that if there is a source in any branch and we are getting any current, specific amount current, say Ix at any particular branch, it will be same if I change this sources, place of sources to the other branch. Say if I just change this current, this source, this is Vs. If I replace this Vs here, then current will be the same if other components are remain unchanged. This is the reciprocity theorem. If this is the Iy, then Ix equal to Iy, and this direction will be identical as per the source direction. Okay, so this is our reciprocity theorem. So one by one we can understand, and then we go for an example so that we can understand clearly. Okay, this is the main things of this theorem, and now we are going to understand realization. First, we have to see some statements which are given for this purpose. Now we examine the statement. You can write down the statement. In any branch of a network, in any branch of a network or circuit, the current due to a single source of voltage V in network is equal to the current through that branch in which the source is source in which the source was originally placed. Again put the branch the current was originally obtained. Okay, so in any branch of a network or the circuit, the current due to a single source of voltage V in a network is equal to the current through that branch in which the source was originally placed when the source is again put in the branch in which the current was originally obtained. Okay, so it will just replace the position of the source, then it will measure the current. Then it can examine that whether it is source was replaced from the another branch, but the current is same as it was originally was flowing when the originally source was placed. Okay, so this thing we can understand easily. Now we can go for the meaning, what they want to say, because this is a something, it is a complex, it is, there is some complexity for the statement. Then we can go for the meaning, and then we will go for the explanation. So in a, not in a, this is simple word, simple words we can state as when the, you can say, when the places of voltage and current in any network are interchanged, the amount or magnitude of current and voltage flowing in the circuit remains the same, not unchanged. Look, when the places of voltage and current sources is in any network are interchanged, then the amount or the magnitude of the current and the voltage flowing in the circuit remain unchanged. Okay, so if we, if we say this is a network, this is a network, say here is a current source, here is a voltage source here. If we replaced the, replace the voltage source and the current source, keeping the same circuit, but we replace the position. Okay, so this current source is here, this is R1, this is R2, this is R3, this is also R1, this is R2, R3, but here we just change, we change, this is current source and this is voltage source. So the current will be magnitude of the current, say this is I1 and this is I2. So I2 equal to I1. Okay, because the source are not, source are amount of source are not reduced. It is just replaced its position. So due to this position, circuit will be, the current should be same, because it is also, say this is the X voltage, this is also the Y current, ampere current. So whenever only you as whenever we apply the superposition theorem. Just like superposition theorem, if we determine this, so for this x voltage, current is flowing, say, ix amount. Okay, and for the only this source, when this source is replaced, if current was flowing, that is also iy. So in this branch you can say that is ix plus iy. So this thing happens when the source is replaced its position. In case 2, you can see when here is the current source. So current source open and voltage is there. So here also current is flowing, that is I Ix dashed. And if I replace the voltage source by shorting it, just like applying superposition theorem, just applying this superposition theorem, and again it is uh, coming the current source, it was the ya amount current. So for this, it is current is flowing through this branch. So for this branch, that is iy dashed. So here the resultant current is ix dashed plus iy dashed. So this and this amount are are same, because just it is replacing, but its direction was just identical to these sources. Okay, so direction may be changed, but that's why the magnitude of the current, magnitude of the voltage is, it will be the same, because no extra sources, no anything will reduce or include. It's all are same, but it is changing its position only. Okay, I think you can understand this. Then we will go for the application, and how could I solve? How could we solve this theorem if this type of problems are coming? Look, what is the application of this theorem? This theorem is used to driving many DC and AC network which have many application in the electromagnetism and the electronics field. Their circuit does not have any time varying element. This is the application. Means where electromagnetism are working, when or the electronics field, they are this circuit may be affected by the other sources. Okay, so in these cases we have to determine and which this branch currents and which are the affected from this other circuit. Then this type of theorems are required. This is the main application, and now we can go for the elaborately explain this theorem so that we can understand very clearly. Okay, the location of the voltage.
Sir, your board is not visible.
Yes,
Uh, Visual, sir.
yes, it is visible. Okay,
Yes, sir.
okay. Okay, the location of the voltage source and the current source may be interchange without a change current. However, polarity of the voltage with the direction with the help of look in this circuit. Okay, this is R1, this is R2, this is R3. So the variance resistance R1, R2, R3 are in this, it is connected in a circuit, and this the voltage source V and this I. But if we change this, if we change this position, then also the current through this branch will be the same. Okay, current through this branch will be the same, and this polarity should be the identical to this. Look, this is a positive, this is also positive. You can't change, that is, this is positive, this is negative. No, you can't change, this is the circuit. No, it is not applicable. But if only you change this place, interchange this place, then nothing happens. No, same current will be flow, same current will be flow, amount of this same current, it will be flow. And what is the limitation? It is applicable only to single source network and not in the circuit should not have any time varying. Second point, the element. Okay, now we go for the step by step so that we can realize. Step 1, select a branch between which the reciprocity has to be established. First, select the branch between which reciprocity has to be established. Okay, then step 2, the current in the branch is obtained using any conventional network analysis method. This method. Second, step 3, the voltage source is interchanged between the branch selected. Okay, then step 4, the current in the branch where the voltage source was existing earlier is calculated. TD. Now this is your last step, then we'll go for now it is seen that the current previous connection, i.e. in step 2 and the STP step and the current which is get when the source is entered, i.e. each other. Okay. Now we will go for an example, real-time example, so that you can understand this thing clearly. So this is an example. First, you can see this is 10 volt, this is 2 ohm resistor, this is 3 ohm resistor.
হ্যালো, হ্যাঁ বলো।
So this terminal is X, that is I1, that is I1 current is flowing, and now this is I3, and that is I2. Okay. Okay, now I am doing here step 1. First, equivalent resistance across this X and Y is given by the, this is X and this is Y. Okay, and this is A and this is B. Okay, so the equivalent resistance across this X and Y is given, the equivalent resistance is given by R equal to, look, you have to watch from this, so it is coming over here, 2, this 2 and this plus 1, means we have to encounter from here, 2 plus 1, that is 2 plus 1, and it is parallel with 3, again after then it is series, so it is coming, 3 parallel 3, then 2, it is actually coming 3 into 3 plus 6 plus 2 equal to 2. Okay, so this is 7 by 2 equal to 3.5 ohm. Then I1, first we are selecting this I1, I2, I3. Okay, so I1 is the, if we apply the current division rule, you know, this is the voltage source 10 volt, it is the total equivalent current. And what is the branch current? If you go for the branch current, here is the main equivalent circuit, this is the I1 is this by this is total current, it will be coming 2.86 ampere, that is total current. that is total current. Okay, and if we go for the branch current, that is I2. I2 is, that is the total current 2.86 into opposite resistance. I2 means this is also 3, this is also 3. So this is the opposite resistance 3, and the sum of this resistance 3 plus 3. It will be coming with 1.43 or ampere, or you may say this is, just remember, note down it, 1.428 ampere. Okay, this is truncated to 3. Okay, and now I3 is, look, this is 2.86 into total current, again this 3 plus 3 equal to I 4.3, or you may say this is 1.428 ampere. Now we have to examine, that is step 2. If we interchange step 2, if we interchange this voltage source or change this voltage source position, look, here it is your circuit, here it is your circuit. In previous section, voltage source is in this position, XY terminal, but we have to change this terminal. So we have to put this voltage source over here. So you can see that is identical, that is 10 volt. Others are same, 2 ohm, this is 1 ohm, this is 3 ohm, this is 2 ohm. Okay, look, this circuit and this circuit resistance are identical, but just voltage source will change and it will interchange this position. It will come in this position. We have to examine whereas the current in this branch are just like this or not. Okay, so this is the equivalent resistance is, you can see now you have to start it from here. Okay, means you have to see that is 2 and 3 plus this is 1 plus 2 because this is series. So equivalent resistance is 6 by 5 plus 3 equal to 21 by 5 equal to 4.2 ohm. Okay, you remember this equivalent resistance is changed. Here total equivalent resistance was as 3.5 ohm, but here it is 4.2 ohm. Okay, so I2 is, now this current, main current is, sorry, I dashed 1. Okay, I dashed 1. Okay, this is, and sorry, this is I2, this is also I1, but it is dashed. Okay, this is I3, this is dashed. Okay, here is 2, yes, here is 2, 3 and 1. So here is 1, 3, 2, all are in the dashed form, so that we can distinguish this. Okay, now this is I2. I2 we are going to, that is voltage by total resistance equal to 10 volt by 4.2. It is coming 2.381 amperes. Okay, now we have to find out I, this is I2. Okay, I2, I1 dash, this is coming I2, and means this is the total current. Here I2 is the main current, I2 dash is the main current or the total current, then it will divide it into branch. So it will coming opposite resistance 3, opposite resistance 3 divided by the total resistance. This is 2 plus 3. So I2 is 2.381 into, it will coming 3 by 5, 3 by 5. you can calculate it will be coming 1.43 ampere, or it will also coming in 1.438 ampere. You can see this amount of current, I dash current, and this I current, that is sorry, this here is the I2. So I2 current is just like same. Okay, where this source is there when it was divided, and when this source is there when it was divided, this this is the identical current it will coming. Okay, okay, this is 1.428. It is also 1.438. Sorry, it is also 428, and this is truncated to this position. So whenever it was interchange this position, so the current will be just like the same, because whenever it will this current will be coming in this position, and this position will be this current position will be the same. This is the main reciprocity theorem. Okay, so guys, if you have any question, then you may ask me. Look, this current here, it is coming, the this is the main current, but whenever it will be branch current is there, then you can see this is the same. Okay, here this current, because this is the I2, and here I1 dashed, this is the same, because this resistance, the current position was changed, that's why it will coming same. Don't confuse with this theorem, because if you think that voltage is there, this current and this current will be same, this current and this current will be same. No, this current and this current will not be same, because position is there, so it will be the same. Here I2 is identical to this is I1 dashed. Okay, because circuit is just a mirror option. It is a mirror option. You can see that is a mirror option. It is a mirror. Just like a mirror. So current will be just like a sorry, this is here, this is here. This is just mirror option, but resistance are all changed. So whenever in this direction current is flowing, uh, sorry, in this direction current is flowing, here in this direction current will be flowing. So where after branching this current, this amount current, and after branching this current, this amount of current will be the same. Okay, so this is the reciprocity theorem. Okay guys, okay, thank you, stop it.